everybody, my name is Sarah Schmidt, and in this video I want to teach you about the interior of the planet Earth. I also want to teach you how the structure of the Earth relates to plate tectonics, and also mention how gold came to the surface here in the foothills of California. We know that the Earth formed about 4.5 billion years ago, but how did that process even begin? Well, you take a large nebular explosion, either the explosion of a star itself or an explosion of two nebular stars colliding together, creating a gigantic explosion of hot gases. And as these hot gases spread out in space, you began to have the formation of solar systems. And planetary planets, free planets, would form together with these gases and would start to collide and hit each other until it accredited to become planets. And as they began to orbit around our sun, you began to have these prototype planets that we now see today. At the beginning, first probably just a solid rock material, like how you would picture an asteroid. But over time, as collisions with other space material happened, it heated up our planet into a magma-filled giant ball. And then over time, all of the heavy materials, including iron and all of the heavy metals, began to sink down towards the center, which is believed to what has caused us to have the iron core that we have today. In the early beginning formation of Earth, it is believed that eventually, after many impacts, that the temperature rose to what they call the iron catastrophe, which means the temperature rose hot enough to melt heavy metals. So let's look at the mantle here for a moment, because most of the Earth is actually comprised of the mantle. The mantle lies between Earth's dense superheated core and its thin outer layer, the crust. So what is so important about the structure of Earth? Well, we already know that the outer core is responsible for our magnetic field. But the mantle, which lies above the outer core, is responsible for really everything else going on that we see on the surface. The mantle has what's called convections of heat. So there are these slow convections that are moving up and down, moving the molten rock. And because of these convections, we see plate tectonics on the surface. Now, if only peeling back the layers of our planet were as simple as peeling back this mandarin, we could see what the inside structure looks like, and we could even maybe open it up. But unfortunately, humans have only been able to go a teensy tiny little ways into our discovery of the interior of the Earth. And most of what we have learned comes from instruments. So how do scientists use seismology to learn about the structure of the interior of the Earth? Well, seismologists know that there are these waves that produce both primary and secondary waves. The primary waves are able to penetrate through solid and liquid material, but the secondary waves are only able to penetrate through solid materials. So when there's an earthquake triggered on one side of the Earth, on the other end, they're picking up on waves, the primary waves, but they're not picking up on the secondary waves, which gave way to the discovery that we have a liquid outer core where those secondary waves could not penetrate. So here are some magnets. The Earth's magnetic field is most probably the result of the motions of the liquid in the outer core. The liquid iron in the outer core is an excellent electrical conductor and creates the electrical currents that drive the magnetic field. Earth's magnetic field is crucial to life on our planet. It protects the planet from the charged particles of the solar wind. Without the shield of the magnetic field, the solar wind would strip Earth's atmosphere of the ozone layer that protects life from harmful ultraviolet radiation. So here we are at Auburn State Recreation. And so here we have a couple, obviously many different geographical features. The ones I wanted to point out today are ones that have to do with the interior of the Earth. And so if you look over, I will have a video showing you what I'm describing. It is considered a dike that flows through the rock over here. That is quartz. And now there is something that probably isn't found here in this vein, but in other veins, there is something that comes from the interior of the Earth that is very precious, and that is gold. And so I was wondering where gold came from. How did gold get here? Well, when there were those supernova explosions, it spewed out all those heavy metals, and when Earth came to formation, all those heavy metals were present on Earth. But as it began to form its structure, the heavy metals, along with iron, sank down to the core. So most of those precious metals that are very rare to find today are stuck there at the center. So how do we have gold here on the surface, or gold just below the surface that we mine to? Well, there's another theory for how it got here. Scientists, don't pause again, scientists believe that gold may have come here from impacts from asteroids that still contained that gold material, or possibly that when there were those impacts from asteroids, it stirred up the material inside of our Earth, almost like if you were digging it and bringing it back up closer to the surface. So now we have that gold material up higher in the mantle around the lithosphere. And so as the Earth, over the millions, hundreds of millions of years, when tectonics began and when the plates started to drift apart, we started to experience earthquakes. During periods of earthquakes, mineral-rich water from the ground would vaporize in cracks in the lithosphere and leave gold veins behind. Veins of gold were being injected as liquids into the cracks of metamorphic and granitic rocks. These veins became exposed as the Sierra gradually uplifted during the erosive times of the Cenozoic era. After this period of uplift, rivers were rich with nuggets, flakes, and fragments of gold as they washed slowly downstream. There they sat among the sand and gravel until millions of years later when humans discovered this precious heavy metal. The Earth is a very special place. Science has obtained so much knowledge about the exterior of our planet and our universe, yet we still know very little about the interior of our planet. Without the optimal structure of the interior, life on Earth wouldn't be as it is now. I hope that you learned a lot from this video and also found out what great lengths it took for gold to reach the surface of our planet.